Hello, everyone. Thank you for coming. We really appreciate your interest in Zentral today. We're the co-founders of Zentral. I'm Henry, and these are my colleagues Eric and Johannes. And in the next hour, we'll show you around our product and talk a bit about our workflows using DDM, MDM, and GitOps automation. And we also give some updates to the latest things that are about to come. Okay. Today, Zentral is a bundle of open source tools with MDM and an inventory that is provided as a SaaS and ready to use. So we come with a config as code approach that's quite unique. And we also have a preset hardened client that we bring to the solution that we provide as a SaaS. But first, Zentral was a flop. So when we went from professional services to a product, our revenue plummeted to a third, and we were losing sleep, actually. So what happened? A bit of the background. Back in 2015, I talked my developer friend Eric into writing a TLS remote server for Osquery, so I could use it for my work as a managed service provider. And as Santa came out the same year and required a similar sync server, we called our server Zentral and hooked all up to our Jamf inventory. And then we were touring conferences with talks about our project and somehow ended up with requests for professional services and consulting work from major international companies. And then we launched our company, Zentral Pro Services, in 2019. So the project was there before the company. And in our day-to-day, we were always fixing Jamf. And this became even more apparent when we started serving Monkey to our customers to overcome patch management problems. And during peak COVID, we developed plans to write our own MDM, and we relaunched the company in 2022, now with a bigger team. So we had major tailwinds. Our biggest customer was considering our brand new MDM, and they were pushing for GitOps and config as code, and we followed. So we put all our resources behind, and we were up to something big. But then everything imploded. Teams have been slashed, budgets frozen. Many of you are in your companies have seen this maybe as well, so keep the lights on under high uncertainty. That was a thing. And then on top, our biggest customer jumped ship out of nowhere. So they had invested over 2 years into their Zentral stack. They paid for some of the biggest developments, and then they migrated to Jamf Cloud. So that was a little slap in the face. So we felt extremely disappointed and were heartbroken because the collaboration with them, with the team, had been so awesome, and we didn't think we could be dropped. So it dawned to us that we transitioned maybe a bit too hastily, and the software, of course, had come a long way, but it didn't convince the top management. So what if GitOps wasn't for device management at all? So we figured that as a vendor, we probably facing the stigma that Zentral is a geeky Santa sync server that people found too complicated. And then we ended an ultra nerdy GitOps approach on top. That summoned the ultimate tinker tool, cool for flexing at a conference, but maybe not something people want to run your organization on. So we saw this manifest in our proof of concepts, proof of values for new businesses as well. So some of them were taking off slowly, and we observed that some users did not fully engage with Zentral, so we had to do something about it. And the solution is surprisingly simple. We need it, dark mode. No, our offering wasn't there yet, and we had to address two big issues. The first thing was that we started to focus on the ease of starting the Zentral proof of values. Because before, we had to put users through a lot of setup and processes that was a bit clumsy. And we started to hand over now Zentral production environments pre-populated with settings and all. So last year, we presented our standard hardened client at the Maxis Admin Conference in Gothenburg. And it's how we use Zentral ourselves today. So it's completely defined as code, and because of that, there's no secrets stored in it, and we can share the config as code with our clients or with our customers. And these days, a proof of value with us can start within 3 minutes, where you're configuring the presets to your liking. That is very, very convenient. And the second thing we had to address is, of course, the deployment. So we wanted to deliver Zentral in the same way we did to our old customers, We served some of them even with ready-to-boot images that were regularly updated by us, and then we pushed them even to their CI/CD pipelines so that they could pull the trigger to just do the change, trigger the change of the Zentral backend themselves. But all of this turned out to be very difficult to explain how this works, and it made extra work for our customers. So like getting in touch with the infrastructure team and running through all those questions, how to, maintenance and cost and yada, yada. So, and because our team is small, we had planned to hold out our SaaS offering for quite a while, but it was obvious that we had to start to do our homework for Zentral SaaS option. And this brings us to the first announcement of today, which is Zentral Cloud. So we have developed a high availability enterprise SaaS architecture with separate data and control plane. And each tenant gets its own stack of a load balancer, a database, event store, metrics, dashboarding, and all of that. And all deployments are fully isolated on the network level to contain the impact of security events. And customers can decide to deploy in one of 5 regions, EU and US at first, for data governance. And we secured our SOC 2 Type 1 attestation in May. And we're on track, of course, for the SOC 2 Type 2 for this November. We had a successful pen test under our belt. And the second one is to follow in August. So there's another thing. In the past, we had a minimum spend of 2,000 euros per month to get the fully managed Zentral. That was part of our offering. But we have started to work now on a mini SaaS offering that brings that threshold down. Well, maybe some of you are familiar with the open source offering that we have. This is the Zentral all-in-one images on AWS and GCP. They're production ready, but we only recommend them to be used for smaller deployments, up to, say, 500 devices. And they have been popular, of course, since many years when we started with Zentral 8 years ago, in combination with the open source tier of Zentral. And in the very near future, we want to have an offering for fleets from 100 devices upwards. So these smaller teams can also benefit from the maintenance-free SaaS instance of Zentral that we want to offer. So I think we finally have understood much better our audience. And with the SaaS and the ready-to-use configuration of Zentral, we've taken away some complexity of deploying Zentral and made it a lot easier to start with. So the band of open source tools and of the agents plays out of the box. And Zentral is in a much more convincing business case right now. And we're finally seeing new customers, which we're happy of. And there's already a little wait list for the SaaS. We're excited about this. So GitOps, it's the de facto standard for infrastructure management, but for device management, it's still a bit niche. But there's an undeniable shift to GitOps underway, though, because regulated businesses, often from healthcare or pharma, fintech, transportation, AI, they are turning into GitOps to meet their compliance needs. And you can see it also here on the conference circuit this year, that many talks deal with CI/CD for device management, one way or the other. And when a team is thinking about GitOps for device management, the big problems and questions are, where do you start? What are the best practices? And does your stack that you have right now even allow for GitOps? And how much work is it to build your own? And how much work to maintain this? And how do you deal with the knowledge transfer or the loss thereof when someone leaves the company? And Zentral is not just a ready-to-use stack of open source tools. It's, in our opinion, almost like a framework for device management as code. And you can start right on with it based on our standard hardened client. So IT teams can use it to put rigorous processes in place, document exactly what the state of the device management looks like. And it's the opposite of a black box. And it's highly transparent. Only a few teams today have built complete GitOps device management stacks. And they are tailored to their specific landscape, like Meta, Google, and other companies, of course. And at Zentral, it's our mission to set forth a workable path to GitOps that's easy to integrate and ruthlessly no nonsense. The goal is to provide the shortest possible way between 2 points, no GitOps to GitOps. And I mean, everything you're going to see today is available pre-configured, so you can hit the ground running when you're transitioning to GitOps working with Zentral. So our customers find this helpful and have our config as code macOS client as a playbook ready and as a guide to start off when they set out to integrate GitOps. So of course, our approach here isn't the final word. We want to continue to pioneer this approach with a community. And while GitOps remains new and there's best practices we can borrow from DevOps, standard procedures for device management, these have to be yet defined. And today we want to show you around our product and the workflows that we've laid out. But first, there's 4 basic design principles. And we're calling them the pillars of Zentral today, and we're going to base our demo around them. So the first one is go with the flow. Zentral always strives to go where the Apple platform is going, and we try not to work against it. So for example, we make sure that platform SSO can be deployed with Zentral, and we never had a plan for a custom login experience that would have broken other key OS functionalities. And in the same way, we have integrated our tools Santa, Osquery, and Monkey, where we stay true to the source. They are not hidden within a branded agent. So if you have learned the tools before, you can keep using them as you were. And you can apply the knowledge that many of you already have. To really make these best breed of tools useful, you have to organize them around one central inventory. And Zentral has a unified inventory to harmonize all of the data it collects and pull all the information from these tools together. Whether you're a beginner or a seasoned practitioner with them, we aim to give you a head start. We provide you with a quality of life improvements like augmentations and workflows that work across all modules. So, and you can organize your fleet with machine tags, for example, to scope the deployment of any piece of configuration, like a Monkey package or Osquery query, a Santa rule, or MDM config profile. And automatic synchronization with the identity providers is also a huge thing that can provide extra information to customize the configuration of the devices. For example, you can use a custom IDP attribute in a user certificate distributed via SCAP. And group memberships can be also mapped to our tags for dynamic scoping. And further custom workflows are possible with our extensive API. And Zentral's architecture is built in an event-driven way. That means that everything ever happens in Zentral is an event. And when a state of a machine changes, Zentral emits an event. And when you change a setting, Zentral emits an event. And all of this makes Zentral great for working with security. You can forward all the events to a CM system, or you can use Zentral's event routing and filtering capabilities to scope exactly what you want to ship. So sorry for that. And the biggest one is that with Zentral, we aim to have everything defined as a Terraform resource. So using Terraform was an early design decision, so we could have not built we would not have to build our own pipeline system. So keeping device management configuration is pretty delicate, of course, and because we cannot allow it to break. Terraform is very good at managing state with its CRUD operation, create, read, update, and delete operations. And Terraform will plan the deployment, tell us what's going to change, and apply this after we've given them the green light, or given it the green light. And device management as code allows here for super rigid processes where we always can show what the configuration was like on a given day, and peer reviews make it much harder for mistakes to hit production. So I've talked a lot about our journey and highlighted many key elements of our product. Now let's turn up to Eric for a demo.
Hello. Yeah. So let's see if the demo gods are with us. Yeah. So the screen is not showing up. What?
No, you have mirror.
Yeah.
Mirror it.
System settings. display. Mirror.
Mirror is here over there.
Yeah. Mirror for black magic. That's it?
Yeah, so you're trying to make the same image on all
Yeah,
the
yeah,
screens?
yeah, that's the thing. Yeah. Good. I'm not good at using computers. Just like I can configure them maybe. But yeah. Is it big enough?
Yeah. Yes.
Yeah? Okay, let's see if if the web design doesn't break. So yeah, this is Zentral. It's a bit weird that I'm standing in the front of it, but yeah. This is Zentral. This is the inventory we are talking about. So this is one of the key things we have. Inventory of hardware assets and software assets. You can see already that we have like different sources of inventory, and we bring them together in one schema that is the same across all the technologies. So obviously, like different technologies provide different information, but we really want to put it in the same schema so that you can reuse it and so that there's a unified view on the systems. Yeah. So let's take one of the technology, just like, for example, the MDM, to filter the machines. This is not a bug, it's just like a filter. Here we can see like this. We are showing our devices, so that's why we have to blur it out. I'm going to pick my machine. That's a bit weird here. Up. And yeah, you can find again the four sources of inventory. So you can see that some of them provide like more information than the others, but yeah, it's all the same system. What you have also, you can have like, for example, we collect the apps, of course. Yeah, it's like we collect Firefox, for example. And you can see that the different sources of information, some of them contribute better information than others. So you can see, for example, the benefit of having Osquery next to the MDM, because the MDM can tell you a little bit about the apps, but actually Osquery has a much better view. And Monkey as well has a very, very good detailed view on all the apps. We have, for each machine, we also have events. We're talking about that. So here you can have like a view of all the events collected for this machine. And there's a lot of different events. So apparently, my machine is just in the middle of a Santa run. So if I can reload this, it's probably going to be, yeah, that was a Santa run. So here you have like all the different kind of events that were observed for these machines. For example, I don't know, we can take Osquery results. So we can see that we have our compliance checks, the packs that are running in the background, and the results are logged here. Obviously, we are going to present the results much better, but if you want the raw data, this is the raw data. So an event is always structured like that. You've got the metadata. So you see the user agent actually, so you can see exactly which version of the agent is running. You have the IP address. This is a metadata, and this is a payload. We are planning on displaying the payload a bit better, but at first you have access to the raw payload. And all these agents and all these events, so there are some inventory events, for example, as well. Let's have a look. Yeah. So what happened here? Let's have a look. Somehow I decided to have some information about the machine. It changed. All these things, they contribute to the health of the system. Tom was talking about earlier in his talk, was talking about having what is important is having like heartbeats. It's like seeing like if a machine is still connected. And actually, like you can see, like some of these events are marked as heartbeats. So it means like it's a proof of life. And we resurface the latest of these events, grouped by user agents, and we resurface them here, so that you can really see, like if something is broken. Like for example, if the latest event from one agent is really different from the other one, that means like at least something is happening. Yeah.
Is that just a naming convention, or is that actually a
The heartbeat,
Yeah.
because we decided, so all the events, we also unify them. So, for example, we don't take a Osquery event because Osquery is already emitting events. But we just put the payload inside an envelope, and this envelope is always the same for all the events. So we have our own Osquery events, but it's a payload inside an envelope, and the envelope contains the metadata. So back to your question, we just decided ourselves that some of these events are heartbeats. That means like we think that if we get a result from Osquery, that's a proof that the machine, if we get like, no, it's not a result actually, it's when we get like a request for the config, then we consider it's an heartbeat. That means like the Osquery is alive. We get like, so you can see we integrated with Monkey with a pre and post flight. So those are our scripts. So we think like when there is a pre-flight, it's a proof of life. And this is really, we think it's really valuable because you've got the version, I've got the last time. So for example, if you distribute a new version of Osquery, you will have like 2 heartbeats, the last one of the previous version and the new one for the newest version. And these are only, it's not magic here, it's aggregations of events from the event store. Okay, so that was the events, the heartbeats. What else do we have? Here you can see like, it's not, we are going to work on this. It's a long list. It can be even a longer list, like if you implement like full security systems, could be like 150 compliance checks. So we're definitely going to work on that. But yeah, so you've got like compliance checks. And compliance checks, we have like 3 sources of compliance checks. We have the inventory itself. So we check the data of the inventory. We have Osquery queries, they can be compliance checks. And we have scripts that we run with Monkey, and they can contribute to compliance checks. We are going back to the Osquery and Monkey scripts compliance checks later. And first, I'm going to show the Osquery, the inventory compliance checks. So at the bottom, there is one. It's a very simple one. It's just making sure that Osquery is on disk. So I'm going to click on it. And you can see, it's called James Path. I don't know, it's really small. Basically, it's a standard for querying JSON. You can have it, for example, in the AWS command line interface. If you want to customize the output of a command line, it's this language that you can use. So it's a standard. And basically, we are looking at all the project is old. When we started Zentral, it was called OS 10, not Mac OS. So sadly, the schema is still OS 10. We look at all the instances, and we look at the bundle path, and we're making sure that we can find this. And we evaluate that on the data in the inventory. Every time the data is updated from the inventory. And what does it look like exactly? Why are we looking for that? So I'm going to show you, like, this is, for example, the raw data of the inventory. Okay? So you can see this data structure. It's in the back end. This is exactly what you have for each agent. And here you can see like the instances and the bundle path. So if one of those has the bundle of Osquery, so this is this, then it's okay. Otherwise, it's a fail. But think of that, like any field here in this inventory, you can run a check on it. So even if you have, even if you are pulling inventory data from Jamf, you could actually run a compliance checks on this data structure. So even if you are migrating from Jamf to Zentral, you could do compliance checks already. So this is the structure. I know it's a bit intimidating, but it's the precision, and all these fields are the same for Monkey, Santa, Osquery, and the MDM.
And this is reporting that your app generates?
Yes, we translate it and we put it there. Every time something happens, we have a diff event for any of those. So you can filter the events as well. So if I install an app, it's going to be an app install event. It will be based on this data structure. Yeah.
Do you provide a schema for your, like with the data types and things like that?
We should. That's a great point. It's really defined in the code, but we don't provide a JSON schema or stuff like that.
Yeah, because like one of the problems I run into is I'll get a JSON doc that has a blank string in it, but the schema, it says it's integer.
Yeah. Oh, yeah.
If you
That's.
try to typecast a blank string to an integer, it just fails.
Yeah. We learned it the hard way because the event store is Elasticsearch.
Yeah.
And for you, the detail is that basically Elasticsearch is great, but it's too much magic sometimes. So it's trying to index everything. So the first time it sees something, it sees, for example, if it's an integer, it's going to be, this field is going to be forever an integer. And the thing is that if one time later it's a string, then it's going to refuse to index this document and to record the document. So it's a valid, very valid point. If it's a string, it's better to interpret it as a string. It's not going to block later on. We can provide a schema for that. That would be useful. We have a schema for the events, at least for the envelope, because it's useful to integrate with CMs, for example. So that's a lot of information about the inventory, but yeah, that's the key piece of the inventory. Let's have a look at my notes if I forgot something. Oh, my laptop is. I'm sorry. No, I think it's fine. So yeah, so you recognize a bit the pillars. I'm sorry, I'm going to repeat them, but yeah. We have, sorry. So we have events, we have unified view, visibility, and all this stuff. By the way, configuration as code, this compliance check, has been configured using Terraform. So don't be worried. The first time we see Terraform, I'm going to explain what it is. So I'm going to look for the compliance checks, and it's here. Okay? So I don't know if you can see it correctly. Is it big enough? Yeah. So you recognize the check. It's here. So what is Terraform? Terraform, you need to describe your resources. You need to write, config as code means you have to write the resources as code. And Terraform has this language. Some people call it the Terraform language or HCL. And this is what you see here. It's a very convenient language. It feels like, oh, yet another language, but actually it's a very useful tool. So you have a resource. That means a configuration object, a piece of config. We've got the type of the resource, so it's a compliance checks. And we have a slug for the resource. It has to be unique per resource. It's a way of referencing something. And here we just describe the fields that are not default values. So we are just saying like, it's a Osquery installed, stuff like that. When you use Terraform to apply it, it's going to call the API on your behalf, and it's going to create or update the resource in Zentral. So the compliance checks that we've seen in Zentral, this one. So if it deviates, it's going to put it back on. So it's better to do the work in Terraform. So again, even the inventory, the compliance checks are managed using Terraform. So that's it for the inventory. I think it's enough. There's a lot of details. We can move on, maybe to talk about the MDM. So here we go. We're going straight for what is called a blueprint. I mean, yeah, there's no trademark on it. It's a blueprint because it's a map of a configuration, and it's putting together all the bits of configuration for a given device. We have different blueprints. You can do dynamic scoping, but at one point the dynamic scoping stopped making sense. So it's easier to see, like, for example, that a bring your own device mobile is not going to be managed exactly like a macOS client. So you can organize your different blueprints. And you can actually, via the enrollment, say that if you are coming from this enrollment, you are going to get this blueprint. And for example, you can have different DEP mapping in your Apple Business Manager or Apple School Manager that will direct your device to one of those blueprints. So let's take the default blueprints. It's the blueprint we have on all your laptops, company laptops. You see, like, there are some values that we don't want you to have to do, like, all the mobile config work. Of course, you can do all your mobile config and stuff like that, but for some basic stuff, we just manage it for you. So this is just the inventory bit. if you don't want, you can switch it off. For example, if you have Monkey, there's no really need to collect the apps using the MDM, but here it's just like for show. And here you can see we have a default configuration. It's a lot of default thing. A default configuration for 5 volt for the key escrow or to enable it, for the recovery password, so recovery lock or firmware password, and the software update enforcement via DDM. So for the 5 volt configuration and recovery password config, there is only one config possible per blueprint. So if you want different configs, you have to have different blueprints. For the software update enforcement, we want you to be able to have different ones because you want you to be able to enforce, for example, for your Canary devices, you can say like, I want the latest and greatest 7 days after the release. And for the rest of your fleet, maybe you leave it at 15 days or 3 weeks. So it's stuff that you know. You've all configured it probably, or someone on your team. What do you want to display as escrow? If you want to disable, if you don't, of course, we support the 5 volt during setup assistant, the macOS 14 way of doing it, which is great because it's happening as early as possible. But if you don't do it, of course, like all the options that you know. And you can see here, for example, that if you have configured one 5 volt and you want to reuse this configuration across blueprints, you can connect it to different blueprints. So the same configuration. Again, you can find this configuration here. So I'm taking the default blueprint. Having a look at the default blueprint, you can see a resource that is a resource for a blueprint, and then the 5 volt configuration as code, which is pretty neat. And you can see that, the link is here. So this is why you have like the type and the slug and then the attribute on the object. Because so you can see that this actually is going to return an ID once it's created, and you cannot guess the ID before it's created, but you can reference it using the language. And this is how you do connections in Terraform. You reference the type, the slug, and then an attribute, and you can put it back. So here you can see that it's a list, because we could have more than one software update config. I'm going to show the software update config, not in the GUI, I'm going to show it here. So it's a DDM payload that we deploy for you. And you can see there's a little twist. We are not putting like directly the target OS, so it's not like 14.5. It's up until 15. And it's 7 days after the release. It means you don't have to change it. It's always up to date. So it's always going to put the declaration that is the best OS for your device, for each device, 7 days after the release is going to be enforced. If you want to target a release, you can. There's another way of configuring this, where you can put the target OS and everything. And what you can do as well is you can put a tag on it. So for example, you can say, I want to test this one, exactly this one. I want to distribute this one to the Canary or to my dev team. You could, and you can attach them to the same blueprint. And the one with the tags is going to be in scope and take over the ones without the tags. And you can see like all the other different resources. You can see what we call the bootstrap package. So it's basically like we distribute Monkey to kickstart the whole thing. It's the first package we installed during the setup of the machine to connect like the rest of the application. There's a little bit of configuration about the recovery passport. Because it's default, there's only a name on it, but it's going to do the escrow for you. Every secret in Zentral is stored encrypted on AWS. So for the cloud, for example, we use a KMS key. So basically, it's a key that is managed by AWS for us. It means that the backups that we use from AWS as well, they don't work without the key. And we are thinking of offering, like for premium customers, a way for them to bring their own key. So they could give us the KMS key. It means like if they don't want to work with Zentral anymore, or they don't trust us anymore, they can remove access to the key, and then even us could not read the 5 volt thing. So we think it's a very So the recovery log, private recovery keys, all these kind of secrets are really encrypted in a database. So a database is encrypted on disk or whatever. It's AWS, but we encrypt the data. So this is it. I mean, let's go back to the GUI because we have a GUI even. Yeah. So let's have a look at the device. Let's have a look at my device. So yeah, MDM user channel. You get the same DDM on the user channel as well. We don't break it. This is a link to the blueprint. This blueprint was generated because of the DEP enrollment, but you can change it if you want. DEP assignment, this is connected to a DEP server. I mean, it's part of one of the pillars. If you know MDM, we are not going to hide it. We try to make it easier, but if you know it, we try to use the same names, the same fields, and we don't try to reorganize it. It's going to be like where you expect it to be, at least. And if it's not, then tell us. There's only one thing here, it's called blocks. So basically, it's going to release the device, but it's going to refuse the device to, because you can release it, but then it's going to re-enroll. No, this one is going to stay like forever, as long as it's locked. The bootstrap token, you've got some, so here, for example, you can reveal it. Revealing a secret is going to trigger an event. So it's going to be in the audit trail. So revealing this would trigger an event. So you can have your security team monitor them, for example. So if there are like hundreds of PR keys being viewed, that's probably a problem. So you've got what we call the artifacts, so you can see like the profiles, the version of it as well. It's important. We keep the versions. We don't update profiles in place, and we know so that you can see like, oh, if it's version 1, you know exactly if the values that were deployed, and because you have version 2. And the commands. And again, still like all the MDM queries. You know when the APNS is sent. You know when the first request is done. I'm going to do it here. I'm going to poke the device, and hopefully we will see the events. And the commands, and you can do, we pre-wired like some commands, and if you want, you can really go and push whatever you want. So this is God mode. Push any command. I'm probably going to do that with DDM. I'm thinking about the best way to present that, but not yet, sorry. Yeah, we think it's nice to have tools to be able to, I mean, some people ask for it, to be able to debug or learn the technology. So this is it. Oh man. What else do I have? Yeah, some payloads. Yeah, going back to the code. Yeah. Oh no, sorry. I said I was going to show the events. So yeah, let's have a look at the events we generated by poking the device. So I'm going to look for my device. Where is it? Yeah, this is the device. I'm going to look at the events. If I look for the MDM device notifications, basically the APNS, this is us right now, pinging 2 minutes ago. And the MDM request is probably like a idle connection, idle, there. So this is a full MDM request here. That happened like 1 minute afterwards. So we know that it's responding. And if you don't see a request, that means like the device is not responding. But if you don't see a profile being installed, you know that the reason, because it never connected after we send the APNS. So it must be sleeping, no battery, no network. At least you know it's I mean, we want it to be as much information as you need. Another thing, let's talk about the config profile. So for example, here we have a demonstration where we have a full Okta integration, so with platform SSO, verification. There's nothing specific to Zentral. It's just a bunch of payloads and a SCEP certificate in the user keychain. So how did we configure this? So let's have a look at the artifacts. So you can see, sorry, I'm going to look for Okta. How does it work? It's Safari. It's computer. So here, the user certificate, we put a reinstall interval so we can manage this kind of stuff for you. We are not going to do some magic like looking at the payload and or the certificate is just like, it's brutal, but it works. Like if after 180 days, we are going to resend it. And we try to resend it as long as we don't get the, yes, of course, I've done it from the device. There's always the artifact is the thing that is linked to the blueprint, and there's a version of the artifact with specific information. So here it's a profile, but you can have, like, for example, an enterprise package. And here we are reading the actual mobile config, so you can work with your own. The interesting part here is that we can benefit from the full, so file-based 64, for example, this is a function from the configuration language, great. It's really practical. So we are reading the files, and the files are on disk. And here we have, for example, the Okta SCEP. It's a standard mobile config. And, oh, sorry. How did I do that? I have to do this, I guess. Yeah. And, yeah, I want to show it here. Up. Yeah, basically, you see, like, we have, like, variables, like all the other MDMs. And this one is really great. It means we take the realm user, so DEP authenticated using Okta. Okta is giving us information. We call it like the realm user. And then we have a dot, and we can get some information out of the signed attestations that we got from the identity provider. And we can put them in whatever payload we need. And because it's a user channel, we can put like some realm user information also. We did like for the POV with Adam, we did like some mapping of other attributes. So you can even map some attributes that you have two custom attributes that you can map. So if, for example, if you want the department, we don't have a department, we have a custom attribute, you can map it, put it in your SCEP. The other thing is that we can put secrets as well. So for Okta Verify, where's my mouse? I cannot see it. Ah, here. I was just blinded by the bloody video projector. Why do we have?
I had the same thing happen yesterday.
Yeah? It's blinding me.
It is very bright.
Yeah. Oh, was it the PSSO? Which one? Oh, let's have a look at the artifacts. Sorry. Here, probably. Yeah, there's a secret. It's for the. Ah, yeah. So we can pass secrets as well. So here, for example, this is great. So you need a secret to connect a monkey to Zentral, but you don't want to have it in your code, and the secret comes from the enrollment. So type, enrollment, address, default, attribute, secret. So once the enrollment is created, we get the secret in Terraform, we pass it as a variable to the mobile config, which is a template, and then that injects the secret. And then like this piece of configuration, we can share it with our customers because there is no secret, it's coming from the deployment via Terraform itself. So this is a kind of neat trick that enable sharing, code reuse, collaborations, and it's just like best practices, no secrets in your code. You can also, if you have a secret, for example, I don't know, a vendor key for a license, put it in your GitHub, repo secrets, or in your, if you connected your GitHub with HashiCorp Vault, for example, to control access to secrets, put it there, and you can inject it during build time and deployment time. That's best practices as well. So this is the MDM, get the idea. I mean, we are all cooking with water. We can only do what Apple enables us to do, and we try to do it the best way and the more transparent way, and we try to just do it like are we supposed to do? And if we are not, just tell us. That was the MDM, a lot of time on the MDM. How much time do I have left? Oh, plenty of time. Yeah, trying to look at the timer that is really close to the beamers. Yeah, it's hard. Okay, so we have inventory. Any questions? Huh? You can always interrupt, no problem. So we have like this thing called Monolith and Monkey. A question, okay.
Hello, check. Okay. There was a thing in the UI that you showed earlier and the question was, does creating that thing in the UI generate the Terraform code in the background, or is it the other way around? Is it that the Terraform code sets the config and that's reflected in the UI?
Very important question. We have something that is called like a Terraform export. So if you started in a GUI, you can export what you've done. But then you have to stick to one or the other. I mean, so we help you kickstart the thing. We even give you like the Terraform that we use to configure, to pre-configure your instance. So if you started with a full hardened client, we will give it to you. You can keep on working on it based on that. But at one point you have to decide. What you can do as well is you can do partial work. Like you could say like, okay, I'm going to manage Monkey Monolith with a GUI, do the MDM with a thing. It has to be separate. If you cannot really manage the same resources because it's going to drift. You have to enforce one or the other. But we have exports. We give you everything. We kickstart everything. Even if you started with a GUI, you don't have to, oh, I'm going to lose everything. No, we will give you like the Terraform. But it's more to migrate to a Terraform workflow than to do it every time. And we use Terraform for that because we didn't want to reinvent version control and implement that in the is something we had to test the candidates. We wanted to be software engineers bias. Like if you want to have like your own version control, or would you go to implement this? And it's a nice interview question. It's not something you want to do.
Thank you.
Okay, so Monolith and Monkey. So Monolith is just because, it's a reference to a movie, and all the monkeys are turning to a monolith. So that's it. So two different levels of integration with Monkey. The first one is the pre and post flight. To remember for the heartbeats. So we have a pre and post flight script that does all the connection with Zentral. It does basically. What the usual Monkey integration do, they put the managed reports, the reports, the logs and everything. They report on what has happened. We have our own source in it. We can run more stuff. For example, we have what we call script checks. The script checks are basically user-defined scripts that we can run using Monkey. And this one is actually comes directly from the MSCP project. So you know the Mac OS Security Compliance project. This is what we've done in the workshop. We learned how to do that. So basically we can turn a baseline, the YAML file that you get from the MSCP project. We can turn it into automatically into Terraform resources, and then you can import them. And then we will run them. So it's something we are expecting. It could be. It doesn't have to come from the MSCP project. It can be your own script. Basically, you can run the script, expect a value. We run it for you, and we will put yes or no. And this contributes to the big list of compliance for the device. So this is the second source of compliance checks. There was the inventory checks, and now it's the script. And the third one is the Osquery. We'll see it later. Again, everything is an event. We go to the machine, look at the Monkey clients, take my machine, look at the events, look for Monkey requests. You've got them. Monkey installs, Monkey errors. Everything is attached to the machine, and is attached as an event. We report metrics as well. So if, for example, so the metrics, sorry, jumping a bit too fast. Every instance gets an event store, so Elasticsearch, and gets like Prometheus, and gets Grafana. You get it when you order Zentral, you get that. I mean, you can plug your own if you want. If you want to do a private cloud deployment, but in the cloud you get all of that, and it's all It's all SSO via the central access. So we gate it via the central access. So I'm going to show like what is Grafana, the Grafana what we provide you with. We kickstart things with a few dashboards. For example, the Monkey package. Here you have like the distribution of, not doing a great job at it actually, distributing one password across our extremely massive fleet. The big customer that left us, they had like 15,000 machines. It was fun because it was really smooth graphs. And they had like beautiful burn charts. We have really blocky ones. So yeah, this is the kind of stuff that is possible. We export the metrics. They are collected via Prometheus, and it makes time series. That means you can see not only the last state, but you can see the evolution of a state over time. And you can do really nice things with Grafana. Again, same kind of stuff. We didn't want to have to write our own dashboard tooling. And we can use Grafana, and you got like, you can have dashboards where you can do like some interactive GUI stuff. So if you want to again, you don't have to generate a report. You can simply give access to the people who need that. You can give them access, and they can look for themselves and see if you are doing a good job at patching. So yeah, so it's interactive, and this here is just to remove we do that a lot. You can remove the noise. So for example, if a machine has been active, so this is active in the last day, so it will remove the noise, because otherwise you have like always like a long queue of machines that are not active anymore, and it's going to pollute the graph. So you can have a look at, okay, across all my fleet or across all the machines I have connected within the last 30 days. It will be like slightly different results. So this is Monkey. This is a classic integration of the logs, the reporting for Monkey. But what we have is we have dynamic catalogs and manifests. And that's the other thing, that's Monolith. We try to stay transparent here. So that means it's a manifest. If you do Monkey, you know what it is. It's bringing catalogs together. We have catalogs. Here we have the scoping that you find in every module in Zentral. So everyone is getting the production catalog. Only machines tagged with Canary get the testing catalog. So it's stuff that you know, but it's driven by Zentral. We've got the enrollment package. It's something a little bit different, but it's basically we want to organize the enrollment packages for you. You don't have to package how to connect Osquery to Zentral. We will take care of that for you. And then you've got sub-manifests. So the only thing that we impose is that you don't put packages directly in the manifest. We want you to put them in a sub-manifest. That's actually, I think, best practices as well. And the sub-manifest can be switched by tags as well. So you can switch on or off like a complete suite of software. So you could have, like, for example, I don't know, the Adobe thing, and switch it on only for the graphic department that you synced from your IDP. This is the kind of automations that can happen in the background. Here we can see we are distributing some remediation scripts. They are fun. Basically, we do the compliance checks in the install check, and if it fails, we install it, and the installation is the remediation. So we are going to switch off SSH, for example, but we are not going to switch off SSH on our servers because that would be silly. Yeah. So a thin layer of dynamic stuff, but it's stuff you know, like package info is the stuff you know. And you can see how they are distributed and installed. You can look for them. You can even have like events attached to them. Audit events. This package was added to the distribution. Audit events are everywhere. We are catching up. There are still 20% of the resources who don't have it, but we will have them for all the resources. Especially if you import stuff or you create stuff via Terraform, we want audit events for the changes. So you've got a before and after. This is Monolith. So yeah, we really want the knowledge to be transferable. If you know Monkey, we want you to be able to use Monkey. And if you learn Monkey with Zentral, we want you to be able to take it, and we don't want to trap people into like proprietary hell. We want the knowledge to be transferable. I mean, this is what I always appreciated from open source technologies that are not secret, and we want to have it for us, for our tool. It's already hard enough to find good people, so it's good. It's also good for the managers. It's something like, oh, it's not something new, it's Monkey.
Hello. I got a question. So it looks like you're taking the P list of the manifest and you're translating it to JSON.
Oh yeah, because basically because we don't serve the. So we have a repository. We actually can have multiple repositories. They are driven by you can, if you have a S3 bucket, we can plug it in. We can provide you a repository. There's something called a virtual repository where you basically can upload packages directly to Zentral, and Zentral is going to act as a repo for people who don't know what Monkey is. But then, because of a thin layer of interaction and stuff like that, we actually calculate the catalogs and serve the catalogs directly. So we don't really care for the catalogs. I mean, we care for them because we want testing production, but we are not serving directly the catalogs. We have to change them. For example, to serve from the packages from S3, we actually do redirects that we sign. So you don't have to change Monkey. Monkey is going to ask for a package. We are going to say, go for this on S3, and we are going to send a request. And so that means that we have to control the way the catalogs are sent.
I see.
So the catalogs are used, and yes, we pull the full information and we put it in Zentral so that we can serve it, but we have to change a few things to make it work.
Yeah, gotcha.
Even the sharding and stuff like that. Yeah. We can shard versions with tags. We can do like 10%, 20%, stuff like that. Was the work we did for this client with 15,000 machines. We really want to add like a progressive and controlled rollout, and it's possible. So that's Monolith, Monkey. Well, how much time? Oh yeah, I have to speed up things, I guess. Osquery. Again, you know it. You know the packs, queries, stuff like that. It's all in there. We have, like, for example, the compliance checks pack. You already seen like the results in the machine, attached to the machine. If you can write a query that returns failed or OK in a column, we can take care of it, and we are going to track it as a compliance check. So you can run whatever query we want. You can have it in your events. You can even put a routing key in the event to make sure that only the events with this routing key are going to be shipped to Splunk. So you can run it like really as a backend for Osquery. But if you want the little benefit of having compliance checks on us tracking them, putting them into Grafana, and tracking the status of the machine, you write your query by using failed or OK, and then we will track them. There's another kind of query. There's a lot of integration servers have that. Fleet has that. Collider has that. It's called a tag query. So basically, if this query returns a result, we are going to put the tag on the machine. If it doesn't return a result, we are going to remove the tag. So here you recognize the server tag from our disable SSH thing. So Osquery is putting the tag on the machine, and we are not going to serve. We can use this tag somewhere else. You can run the queries. It's called, I don't know, there's so many names for that. Ad hoc queries, distributed queries, or I don't know, troubleshooting. So you can take a query, for example, this Umbro packages is really simple. It's like, I want all the Umbro packages, or please run it now. And then you can say, oh, it's going to be valid for 1 hour. So every machine, all the machines that are going to show up within the hour are going to get this. You can say also, if it's a big fleet, again, a lot of things are sharded in Zentral because you can have, like, it could be 15,000 machines, and you just want to sample the data, and you don't want to overflow your system, so you can say, like, 10% of the fleet. You save it, you wait for it, it's going to be reported. If it's a compliance check, it's going to update the compliance checks, so you don't have to wait for 1 hour or 1 day for it to come back. If you know that you fixed something, you run it, it's going to update the status of a machine. I think I've waited long enough. No. But yeah, basically, one of a client can show up, and we will get results. I was standing in front of a thing as well. Didn't get results? No luck. But just they are lazy. So that's Osquery. How much time? So yeah, events, truth over technology, transferable knowledge, configuration as code. This stuff is here.
Hey, can you go back to Osquery real quick? And is ATC, is that auto table creation?
Yes.
Oh, that's cool.
Yeah. I was thinking about that because you gave me this idea today.
Yeah.
In your talk, you were talking about the Monkey database. So Monkey has a usage database it's been like 2 years now, I don't know. And it's a SQLite file on disk. Osquery with automatic table creation, so people who don't know, it's basically if you have SQLite somewhere on disk, you can define it, and Osquery can query it. So the idea would be like now, in your default central configuration, we should have like a automatic table construction for this because we install Monkey, so we should have that built in. And automatic table, let's have a look at the. I don't know if we have. Yeah, we should have that. This is the official. We are officially like a provider for Terraform. So let's have a look at the resource. I don't know. Do we have ATC? Oh, we have ATC. Yeah. So you can configure your ATC using Terraform. And this is what you do in Osquery. It's like you define the columns and the names. You define where the file is on disk, and then you can query it as if it was like another table. We should definitely do that. Let's put it on the to-do list. And the last bit is Santa. So it's a bit of an extra option. If you want a full blast like Central, you tick the box, and we can put Santa. It's also a standalone option if you want. So if you have everything, if you are really happy with your MDM and everything, but you want to allow and block list binaries, you can get Santa from us. And there's a little announcement for Johannes later. Santa, so allow and block listing of binaries based on their signature or hash or bundle ID. Here are the targets, for example, a little overview. The agent has been developed and is in use at Google, so it has been tested on X thousands of machines. Those are what we call collected targets. Is something that can be the target of a rule. You see the different types of targets. I'm not standing in front of them. The new ones, the ones you want to use, are signing ID, team ID. It used to be certificate and binary, but they change every time there's a change of signing certificate because it was based on the hash. But now that we can target team ID, even when they change their certificate, we can still target them. Very simple one. We don't want clean my Mac. So this is it. Santa is reporting it. You see in the progression bar, because actually it's analyzing the bundle to give us like all the information about the bundle. It's pushing an event to the machine, to Central, it's blocking it. Why? Because we had a configuration here, and you had a rule, and one of the rules was team ID, MacPow. We don't want MacPow. We are this kind of company. Policy is block list. We are running in monitor mode. More on that later to have workflows to enable lockdown. We can run in more lockdown. The rules, again, everything configuration as code. You can define the rules in Terraform. All the configuration I've displayed in the GUI, it's Terraform. So, and let's have a look. There should be like a blocking event on the machine. Yeah, your machine. So your machine is a laptop, for example. It's probably the last one. Yeah. Let's have a look at the events. Oh, look at the Santa event. Block team ID decision. Santa, the version, the decision, and the full information about the signing chain, the team IDs. Oh yeah, and signing ID is actually, so you see like the new ones, the team ID is signing ID is a combination of team ID and bundle. And it has priority, so you can block, you could block a team and allow one bundle. And it's much better than targeting the hash of a binary that changes at every version or stuff like that. So we keep it because who knows, but it could be like one version, one particular version that is a malware and not the other one. But yeah, you want to work with signing ID and team IDs. That's it. I think do you have enough time?
Do you want to do that IDP thing?
I have a IDP. Oh yeah. Oh, sorry, I forgot. Yeah. Quickly, we have so yeah, Terraform. We have a backend. We can store the state of Terraform directly in Zentral. That can be useful, stuff like that. But we wanted to show the IDP integration. So we have SAML here with Okta, and we have what we have like Scheme. Oh, I don't know. Yeah, Scheme. So automatic provisioning. So when a user group membership changes, we get the event. And what we can do is that we can map the groups to tags. And this is like enable some really nice workflows like group membership. We are tagging all the machines, stuff like that. So if you take Okta, sign out, signing in. Yeah, it's not going to work. I have to enter my password again. It's the demo machine, sorry. But basically, yeah, I mean, you get the gist of it. You change the membership, and 1 second later, the tags are put on all the machines. So if I have 2 machines, 3 machines, it's all the machines because it's the primary user that we use for the mapping. That's it. So Johannes is going to wrap this up and tell you about maybe the roadmaps and what is coming ahead. Thanks.
Thanks, Eric. Now I have to, hang on. No, and also unmirror, right?
Yeah.
Where is it?
We are good at computers.
They're very hard.
Still mirroring. And then we just like go there. Here we are.
Great.
Time.
Cool. All right. Yeah, so we don't think of Zentral as a security company, but our customers often are very security conscious. So I want to briefly touch up on this. So Zentral is a good sort of risk-based approach for the device management. We have a detailed view. We keep our devices up to date. We can detect when the configuration is off. We have the feedback loop. There's good hardening in place. And because it's in Git, we can prevent mistakes, right? Because we have peer review. So we think this is the lion's share of good security posture. And we're trying to make it easy to get there. We've always had lots of people coming our way because of the SantaSync server. And frameworks like NIST, like call it the gold standard. But people often say it's kind of just works on paper because there's no allow list that you can buy. You have to accept the monumental task of maintaining one. And not everybody has the resources, or let's just say almost no one has the resources to do that. Or you restrict your users so much with apps that they can use that, you hamper the user experience. And most find it unacceptable. So as a result, Santa usually ends up as a blocking tool, and that falls incredibly short of what's possible with it. And that brings us to our second announcement. Some of you may remember Upvote. That's the tool that Google had to handle user-bound exceptions. Upvote is no longer maintained, but we have started to develop our own take on it. So it's like with it, you will be able to handle user-bound exceptions. with a voting system like Upvote had. And the other problem is, how do we get to our first allow list? And that will be our spin on it that will help get you to your first allow list. So in Upvote, users vote on binaries. And every binary has a score. And then when the score exceeds a first threshold, the lower one, the app is allowed to these users that voted on it. And then if it passes a second threshold, it's allowed for the whole fleet. And these thresholds can be set freely. And in Google's case, like 5 users was enough to create a user bound rule. And then in the same way, you can give more voting power to certain users, for example, an admin, so they can make decisions. Now all we need is our first allow list. And this is the Zentral sync server. The center agent is running in monitor mode, so it will only enforce the block list. And then every time it detects an unknown binary that is a binary that's not governed by any rule, it'll send an event. And now that Santa handles team IDs and signing IDs, it's easier for us to get to a good allow list quickly. Zentral will keep account of how often Santa has seen a target and aggregates that information. And then in a comprehensive view, admins can vote on these apps and add them to the allow list. And when the target, again, passes the threshold, Zentral will create the rule and then distributes it in the next sync phase. So as the amount of rules increases, the noise floor will drop, right? Because it will stop seeing unknown binaries. And at some point, you can decide it's time to transition to lockdown mode. So now the Santa agent is in lockdown mode and will block every app that's not allowed. When it does, it will send the event again with all the information. So the user sees a popover and gives them feedback, and we'll take them to an exception portal, and there they can vote for an exception after they are authenticated. They'll see some info about the binary so they can make sure their decision is intentional, right? They're not voting for something like real quick. And when the voting score passes the threshold again, Zentral will create the corresponding rule. And because of this power and voting power and thresholds, like how customizable it is, you can have different flavors. Google had 5 users, and it was okay to vote for them to create an exception. And that is thorough peer review, and it prevents mistakes, but it does not prevent the spread of malware altogether. It just massively slows it down. You could also go to the other extreme and always require an admin to vote. So users wouldn't be able to do it on their own. And you could go even further and require peer review for the admin by setting the threshold accordingly. So not one single admin can create a role with their vote. So maybe that makes sense for the initial allow listing process. Or you can find middle ground, maybe give a manager enough weight so they can unblock something for the team. The system is very flexible. And we've decided to make this solution available separately, and we aim to have a beta ready for Mac System in 2024 in Gothenburg. Zentral is a pretty complete product today. We go with the flow. We use Apple DDM, and what's best for patching is Monkey Companion. We integrate it all together with the tags for scoping, big quality of life improvements, IDP integrations. We have visibility, script checks, Osquery, inventory stuff, just big on feedback loops. So you know, your devices are compliant and how big the gap is, in your fleet. With the dashboards, the relevant events, you can filter them, ship them to your team, collaborate with security, and configure as code. Everything is defined in a repository, exact documentation. You can have peer review, and it's very traceable and good for accountability. And the cool thing is that with Zentral, you get it prepackaged, everything all together, agents, settings, dashboards. You saw that. You can have exactly that, and it's taken great teams years to build it, and now you can just start using it with our Zentral cloud thing. So cool. thanks for listening. If you're considering to swap your MDM, then please put us on your evaluation grid. Tell your colleagues that might be doing this. We're just trying to raise awareness for our product. The SaaS is available in August, and we have a few seats left for this year. So yeah, thanks a lot. Please give feedback.
And also, if you don't want to